Hello, hi. Today I will show a little bit manual of how to use CR400s with the Spectramagic software. So we have here is actually CR410, just a measuring it without the data processors, and it's calibration plates, white plates. And we are on the Spectramagic software. So of course, first of all, whenever we want to start using the equipment, of course we have to turn it on first. So I go on and turn it on. And when you turn it on, there's actually you have to click on menu. Just press enter when you turn it on and go to PC mode. And now it's on PC mode. So in this way, you can actually connect it to your computer. Of course. So now back on the screen. First of all, before you connect to your computer, you might want to check your communication setup first. Because if you have a few different devices connected to the same computer, you might have problem with communication port because your computer doesn't know which port is connected to your CR400. So now here in my laptop, we only have one, so that's pretty straightforward, basically. But the way you want to check it, usually you can go to Device Manager, and in your Device Manager, it should pop up the name of the equipment. So one moment here. So this is mine right now. So there's only one. But if you have a few equipment, you might need to check that out. If not, then you can just proceed to the software right now, and right away you can connect. So when you are connected, you will see all the things. What instrument is connected to. So of course, you will see the name of the instruments here. And there's a few setup which you need to do first before going through measurements. So of course, you can check your instrument settings. So when you check your instrument settings, given that CR400 is just a single method of measurement, which is reflectance, it doesn't have any transmissions, and given that it's a chromometer, so it doesn't really have other functions like checking the pigmentation, spectrograph, and all these things. So most of the setting will be off except for this, but it's of course you can't choose anything else, just reflectance. So that's for that. And now, so first of all, initially you have to set up what is your, of course, your luminance and observer. Now, here's the thing about CR400. CR400 can only use 2-degree luminance, so you might want to change that. But the best way to do it is actually to go to standalone configuration and initialize instrument. This way you can reset your instrument. Let's say someone has been using it before, unless you are the same person who is using it. So it's not much of a problem. But if you don't know who were using it before, so perhaps you want to reset it, this is how you do it. So you just reset the equipment, and now it's reset. So I don't know if you noticed, but it was D65 earlier. Now it's C. So initial condition of this equipment is actually on C, and the observer is 2 degree. Now, let's say you want to change that. You don't want to use C because your standard is following D65. Go back to standalone configuration and option, change the illuminant to D65, apply. So now your equipment is also D65 and measurements on your software is D65. Of course, the next thing to do is because on my side now you can see that observer is 10 degree. So I can tell you this will not work because I cannot take measurements using this. So what do? go to observer and illuminant, change it 2 degrees. There we go. Okay, yes, I'm sure. Okay, so now you already set it, and now you can start do calibration. So in order to do calibration, just go here and click your calibration. It will tell you to use the white plate here, which each devices come with. So usually for CR400 you can have multiple white plates, but best thing to do is to use the same plate which came with the device itself. So this way your device is calibrated to correctly. So now using white calibration, of course we don't have data as we reset the instruments. So now we can just input the data. There we go. See, are you hear me? Okay, this is important part. Given that your luminance on your instrument here is D, so make sure you are following the right one, which is D65. So I'm going to input that into my computer. So 93.7, 0.3170. Another one is 0.3334. Oh, now we want to perform calibration. Take off the protective cap. And make sure you're covering the whole area of the calibration head. The measuring head onto the white tiles now to a calibration performance. So you will hear a few flashes of light, this indicating that it's actually doing the calibration. So now you have completed. So now we have the data of the calibration. Just click OK. Alright, so now it's calibrated to this white tile. So now, how do you know if it is properly calibrated? So what you can do is actually you can just take the measurements of the white tile. So let me measure it. White tile cal, and then measure it. So now I receive this value. So let's see. So now I can't really tell you what if it's calibrated because our calibration is using Y, X, and Y. So what can we do here is we can choose different type of data. So let's go here. Now you have a few different, not how do you call it, a list item which you can put. You're basically making new columns inside your data. So now let's say I want a timestamp. Okay, let's put a timestamp. And this timestamp, I'm going to move it to the top. Then here from this, there's Y, X, and Y. And you need to know, first of all, it's a huge Y. Move it here. Oh, bottom. Then another one is X. And then Y. Alright, so this one, we move it up, okay. There we go. So this is the current settings, and you can see from here, let's check if the value is very, very close. So of course you got, first of all, Y equal to 93.7, then very close to what we have. and then X is 0.317. Then another one is for Y, small y is 0.3334. That means that your equipment is rightly calibrated. And if it's very different, very far away from the value of the Y plate, you might have to consider sending your equipment to the authorized service technicians. So here you go. This is the setup of the calibration. So let me delete this so it doesn't interrupt our measurements. Okay. All right. So now, okay, I want to also delete a few things so that I don't get too confused. This one, and this one. Okay. So now, let's say I wanted a different index. So I want a yellowness index, ASTM index here, and whiteness index D65 here. Okay, so now based on this, I can do measurements of yellowness index and whiteness index. But you know what? I want to add more. So now let's add differences by giving the evaluation, like how yellow it is and how blue or yellow it is or green. Okay. So based on this indexes, I can use it to actually check like how yellow or white my sample is. So let's move on. Okay. Now you will have a few different data here. So you know what? I'm gonna remove and do the measurements. So I will take, first of all, a target. I will measure the surface of this table here. So it's a bit orangey or brown, I can say, but also red. So my expectation will be, in order to create orange, will be plus red and plus yellow. So let's see what we get. Table top one. So now first measurements. I get this value, which is, as I mentioned, will be more A, meaning more red, and then more B, positive B, I mean, will be more yellow. So red plus yellow will be very orangey color. And of course, we can check out the okay, we can't check the evaluation yet because this is a target. So let me do a second measurement. Maybe I'll move it up a bit. But those are the same surface. It should give me a different value. Let's go for sample table one. Okay. Now I took my measurements and I can see the difference is 0.26. I mean on delta E difference. So of course we don't see white color here on the table. That's why we don't have whiteness here. It's negative. But we have yellowness because there is a sense of yellow, and of course there is the evaluation less red or less yellow. So if you are wondering if it's working or not, let's test it with our white plate as well. So I assume that given that we now have a white plate, we will have value of whiteness index very high. And I'm pretty sure we might have yellowness index because, of course, white being white have elements of yellowness. And let's take measurements and see how it is. Okay. White cal. So I'm doing it as a sample, not as a master target. Now let's check. So I'm comparing the whiteness with the tabletop. And of course, you can see here, as I mentioned, the white is very, very high, and the yellow is there's some value towards yellow, and there's also less red and less yellow, of course, because we are talking about white here, and with differences quite high actually. So that is basically just showing how the equipment works well. Now, okay, so let's move forward to another important things to do: tolerance settings. So of course, when you have measurements, you also want to control your tolerance, meaning how much you want to let it pass, and how much to make it fail. So commonly known as we go through the training last time, we always use delta E as the reference of our judgments of our tolerance. So I'm gonna turn on the delta E here, and let's say I wanted to increase it to, let's say, 2, and apply it. Okay. Now, on our previous measurement, obviously we can see already some of it already failed. Of course, the white cal failed because it's literally different color. It's literally white, and the delta is quite high. Now, let's do measurements again on the table. Let me take it perhaps a bit lower. Okay. So I'm going to do another measurements again. It's simple. And let's say I want to say sample level 2. Do the measurements again. Now, if you realize we have a warning here. So, why do we have a warning? Warning means you are setting up how far your delta E would be. So, let's check it out again. Here, I have the delta E being 2. Now, let me go to another window. Attachment format. So here, I set here, I tick on it and saying like, if the value of your delta E is very, very close to your tolerance, meaning your setup is 2, then if it's very close, 80% close enough to your target, I mean, your target as in your tolerance target, meaning that you are actually in a failing zone. So if you want to turn it off, just click on this and okay. So now they won't show you warning. But of course, you can also change to any value you want. Matter of fact, you can actually change this to a different color. Let's say you want a very light green. Okay. Oh, oh, doesn't this one change the color? Check again. So this one you can also check. You can turn it yellow. Sorry, green. Now this is also light green. So let's for the um, judgment settings. Okay, so now moving forward. Uh, Assuming that you want to turn your sample into a target, so what can you do? Now just go here. Let's say you want to turn one into a how do I say, a target. Just click this. So you can actually the data properties here. So and pseudo color will show you what color you are measuring. And of course, this is important things you want to do. Okay, so actually you can see on the report here that there's a target here and then your sample. So each time you take a value, you will actually get a new report. There we go. And this can be changed on here on tools and go to edit mode. Now there's a lot of function to go through edit mode. So let's say you want to put this LAB color chart. Let's see. Now you will have all these things. This is LA minus B. Cool. So this is the same as the one that we already have actually here. So just undelete it. Let's say you hmm, let's say you want a spectrograph. I don't think we can have a spectrograph, but we'll see. No, okay, we don't have a spectrograph because this is a chroma meter. So just a reminder that the software is actually universal for most of Konica Minolta spectrophotometer and chromometer. So some of the function might not be useful for you if you don't use it. The reason there's a lot of different when it comes to pro version and light version. Uh, when you're following certain standards, it's the best practice to actually go with a pro version because they have more, how do I say, standards which you can input. So let's say you have a special formula that you're following. Now you can actually just use this, and this can be added here. Let's say I wanted to do L plus B. It's just a function. Let's say you have a specific formula you invented yourself and you want to put it and you want to see how does it work. So now you can just click. Oh, hmm. Now there's the equation for user equation here. So it's of course just some gibberish I invented. It doesn't need to be like that. Anyway, so that's the first part of the video of how to basically use Spectramagic software with a chromometer. So thank you very much.